Hello there! In this Java Basics video brought to you by FTC Team 8610 ToborTech, we're going to learn about the concept of inheritance in Java. Without further ado, let's get started. Before we talk about inheritance in a programming context, let's talk about what inheritance means outside of programming. So we often associate inheritance to meaning a child inheriting the qualities, the personalities of their parents. And in programming, inheritance means pretty much the same thing. Inheritance allows us to have a child class, also known as a subclass, to inherit the instance attributes, also known as fields, and the methods of a parent class, also known as a superclass. So you can think about this just like a child and a parent. The child class would inherit the attributes, which are kind of the characteristics, and the methods, which are kind of like the behaviors of a parent. All Java classes implicitly inherit the object class. So all the classes you have defined so far have all implicitly inherited the object class. So you didn't have to write anything, but they are all inheriting the object class. The object class defines the most general properties as well as the behaviors of any Java class. Subclasses are used when we want to specify more detailed behaviors and properties that are specific to each subclass. So here we have a diagram of a big tree of inheritance. So at the very top, we have the object class. This is the parent class of every single class in Java. And on the second row, we have classes that inherit the object class. So these classes all inherit the object class, but there are more specific behaviors that define each of these subclasses. And these are the classes that you have been making before this video. Now let's look at just this branch right here, the branch that comes out of this class right here. So let's say we want to explore biology for whatever reason using Java. And we can have this class be something like a living organism. So this class is a blueprint for living things. It has behaviors like, for example, live and maybe die, and etc. And here we have two subclasses coming out of this parent class. So this class right here on the left and this class on the right both inherit this living organism class right here. So for example, we can have the plant class and the animal class. A plant is a living creature, which means that a plant has all the properties of a living organism. And an animal is also a living organism, so it has all the same properties as a living organism. But we can define more specific behaviors specific to plants and animals in these two classes. So for example, the plant class, we can have things like, I have no idea, photosynthesize. Or maybe in the animal class, we have things like run or maybe move. I'm just making things up. These are probably not common to all animals, but let's pretend that it is. And coming out of the plant class, we can have subclasses like trees and flowers that are even more specific blueprints for, well, trees and flowers. On the right, we can, for example, have things like reptiles on the left, and maybe on the right, these two, we can have mammals here and let's say dogs and cats. So this is how we can use inheritance to define general behaviors in superclasses and have subclasses that inherit the parent classes, but also define more specific things just for the subclasses. So now let's talk about inheritance in Java. Let's use the example of computers. So phones and laptops are both computers, meaning they all share common characteristics of computers. And because of that, we can let the phone and laptop classes inherit from the computer class. So that way we can define general behaviors like powering on, powering off, and properties like brand in the computer class. Think about it. All phones, all laptops, all have the behaviors of powering on, powering off, and they all have a brand. So we can define these things in a computer class and have the phone and laptop classes inherit the computer class. That way all the phone and laptop objects we'll have the power on instance method, the power off method, and the brand attribute. So we can think about this as, let's say, here. So we have the computer class. This is the computer class. We define things like power on, power off. And here we have the the phone class that define more specific things just for phones. And here we have the laptop class that define behaviors and properties more specific to laptops. So here's an example of such a code that can be written in Java. It's a very long program. Let's take this out one piece at a time. So we have a computer class. This is not very different from any of the classes we have written before. We have a class called computer. It has a private string instance attribute called brand. And then we have a constructor. We just assign brand to our instance attribute. And we have power on, print something out, power off, print something out. And then we have a getter for our brand instance attribute. It's probably a good idea to have a setter for the brand instance attribute if we actually, well, in this case, it wouldn't be necessary because we won't be changing the value of our brand instance attribute. But in some cases, it may be necessary. So here we have our phone class, and here we have our laptop class. And then we have a driver class, a main class to write our test code. Let's take a look at our phone class. First difference from the classes we have written before is the fact that after class phone, we have extends computer. So this is indicating that the phone class extends, it inherits the computer class. This is the superclass, and this is the subclass. So whenever you define a header for a subclass, you would write class, and then the name of the subclass, and then the keyword extend, and then the name of the superclass. So the two subclasses, which are the phone and laptop classes, they each have properties specific to their own class. So we have a property called number, which is the phone number of each phone. Not all computers have that, so we define it in the phone class. This is specific to only phones. And then we have a method called makePhoneCall. Well, we can't really make phone calls from a laptop, so we define this inside of the phone class, which takes a parameter number, and we say we're calling whatever number is passed in. And pretty much it's the same thing in our laptop class as well. We have two private instance attributes specific to the laptop class, and then we have a constructor, and then we have a switch user method that switches the user. Now, the important thing about inheriting a superclass is in the constructor. Let's take a look at this right here, the phone constructor. It takes two parameters. We have a string, which is the brand name, and then we have an integer, which is the phone number of our phone object. The first line of our constructor for both the phone class and the laptop class is super parentheses brand semicolon. Same thing for both. What this is doing is we're calling the constructor of our superclass. So this is a method call. Because a constructor is a method, we can call it. So in this case, we're calling the constructor of our parent class, computer. So we're calling this method right here. And in this case, it takes one parameter. It takes a parameter called brand. And we're passing this input into this, and we're taking it right here and assigning an instance attribute called brand, the value that is passed in. So this is rather complicated, but just think about a phone has a number attribute, but because it also inherits the computer class, it also has the instance attribute brand. And we're using this line right here to assign a value to that brand attribute. And then we say this.number is equal to number. So in these two lines, we are making a phone with a brand that's passed in here and a number that's passed in here. And the same thing with our laptop class. We're calling super brand. We're passing in this value into this method. Notice how the parameters match. The argument that we passed in matches the type as well as the number of arguments in our computer constructor. So we're assigning this.brand to be brand before we say we want this.operating system to be operating system, this.user is equal to user. So this is the important thing with inheriting classes is in the constructor, you'll have to call the superclass constructor, passing in a matching list of parameters. And then in the main class, let's take a look at the objects that we're going to make. So we have a computer object called C, which is a new computer. We pass in the brand Apple, and then we say c.poweron, c.poweroff. In between, we say c.getBrand. So here we use the public getter of the brand instance attribute. We say getBrand. We're going to access the brand attribute and print that out. And then we have a phone object called P, which is equal to a new phone, Samsung. The phone number is 123. And then we have p.poweron, system.println, p.getBrand. And then we have p.poweroff. Now remember, a phone inherits a computer. Therefore, the object P right here has the method poweron. It inherits from the computer class. So it has the poweron method, it has the poweroff method, and it has the getBrand method. So we're able to call these methods from a phone object even though it was defined in a computer class. And that's because our phone class inherits from the computer class. And then lastly, we have a laptop, which is a new laptop. We pass in the values of HP, the operating system is Windows, and the username is admin123. And then we also can access power on, power off right here, and get brand right here. And then we have more specific behavior, l.switchUser, admin321. So we're switching the user here. Let's take a look at what will happen if I copy this super long example program into our editor. And we get powering on, Apple, powering off. So this is expected because we have a computer class and we have everything defined in the computer class. So we can power on, we can print out the brand, we can power off. But here, when we say p.poweron, this is a phone. It also can print out powering on. That's because of inheritance. Same thing with p.getBrand, we get Samsung, and then p.poweroff, we get powering off. And in between, we have make phone call 321, so we have calling 321. Laptop, same thing, powering on, then power off, we have powering off right here. HP is the get brand return value, so we get it printed out right here. Now, inheritance only goes one way. A subclass inherits a parent superclass. We cannot access, for instance, the make phone call method using a computer. So what if I write here, let's try, if I write c.make phone call, and let's say 111. If I do this, we're calling the make phone call method on the computer object. This will raise an error telling us that we cannot call the make phone call method of type computer. It does not know what this is because it was defined in the subclass phone. Same thing with our switch user, which you can probably guess will also raise a similar error. So a computer is the parent class of a phone and a laptop. So a phone is a computer. A laptop is a computer, but not the other way around. So let's scroll down here and let's take a look. Something to note is that the private members of a class are not inherited by subclasses. So private members can only be accessed in that class. It cannot be accessed anywhere else. So for example, in our example up here, the private instance attribute is actually not visible from the phone class. So if I want to access the .brand of a phone inside of the phone class, so let's say here I want to let's just say calling the number, and then let's just say for whatever reason we want to print out the brand. There's no reason for that. Let's just see if it works. So brand. Now, supposedly you would think that because we're inheriting brand, or if we are, then we would be able to print out this .brand from our make phone call method in the phone class. But in reality, because the brand attribute is defined to be private, we cannot access it in a subclass. And we get two errors because the first one is the fact that our this.brand, let's see, this.brand, right? This is right, and the other one is just because I added this line right here. Let's remove this and run this. And we see that brand has private access in computer. Brand is private, it can only be accessed in computer and nowhere else. So even in a subclass, private members cannot be accessed. So how we go around this is the same thing as how we go around all other private fields, is we use getters and setters. So we cannot access this value here, but we can access the public getter right here. So we can say this.getBrand. And we would see that in our make phone call, we would see calling 321, and then we see Samsung. No reason why it's in make phone call, but let's just pretend it's a normal thing to do. So private members cannot be inherited by subclasses. That's just the important thing to know. You have to use public getters and setters to access and modify private fields in a subclass. Now, using the example above as a model, write a superclass with one or more subclasses inheriting it. So if you need some ideas, consider things like transportation vehicles, like cars, planes, trucks. These may have interesting inheritance behaviors in them. And then things like animals and plants that we talked about in the beginning of this video, as well as things like jobs. Now, to summarize today's lesson, inheritance can be very complicated and very hard to grasp at first. So make sure to practice a lot and you'll understand it gradually. And that's it for this video about inheritance in Java. If you have any questions, feel free to leave them in the comment section. If you learned something in today's video, please consider subscribing to our channel down below. With that said, thank you very much for watching this video, and we hope to see you in future Java Basics videos.